Hello and welcome to AI Research Roundup. I am Alex. Today is May 10th, 2025. We are looking at a research paper from Hugging Face's list of trending papers published just 5 days ago, titled Invoke Interfaces Only When Needed, Adaptive Invocation for Large Language Models in Question Answering. This paper tackles how question answering systems, AIs that answer your questions, can efficiently use both large language models and small language models. The goal is to know when a small language model might hallucinate or generate errors, and then call the more powerful large language model. This research introduces a metric called AttenHScore, which helps make this decision in real time by spotting potential reasoning errors. This figure provides a great overview of their collaborative framework. At the top, a query first hits the small language model. Then, hallucination detection, using AttenHScore, decides to accept the answer or call the large language model. The bottom shows the small language model generating an answer, sometimes using Retrieval-Augmented Generation by pulling in related text. Here, the real-time hallucination detection for Invocation, or RHDI, checks tokens, essentially words or parts of words, by combining probability and attention scores. If this AttenHScore overchunks passes a threshold, it flags an error. Alright, this first table really shows how well that AttenHScore works. It compares AttenHScore against other hallucination detection methods across several datasets and small language models. The key metrics here are area under the receiver operating characteristic curve, or AUROC, a score from 0 to 1 showing how well it spots errors, 1 being perfect, and accuracy, or ACCR, the percentage of correct detections. AttenHScore, in bold, consistently outperforms. For example, on the squad dataset with Llama 3 to 8b, its area under the receiver operating characteristic curve is 0.8715, much higher than eigenscore's 0.7359. Moving on, this next table looks at the overall question answering performance measured by the F1 score, which is a way to gauge accuracy by looking at both how precise and how complete the answers are. First, it shows their uncertainty-aware re-ranking process significantly boosts the small language model score on its own, from 13.25 to 16.62. Then, when collaborating with large language models, the AttenHScore method consistently achieves the highest F1 scores, often getting very close to using the much larger and more expensive large language models alone. Okay, so this next figure, figure 3, delves deeper into that uncertainty-aware re-ranking for Retrieval-Augmented Generation. It is comparing their re-ranking method, those are the bars starting with a G, against several standard re-ranking models. We are looking at performance using metrics like mean reciprocal rank at 10 or MRR at 10, which tells us on average how high up the best piece of retrieved information is in a list of 10, and hits at K, which checks if any good information is in the top K results. Their G methods generally show strong results here. Building on that re-ranking, this final figure, figure 8, provides a comparative analysis of different methods within the large small language model collaboration system. We see overall question answering performance represented by these bars. At the top, large language models alone set a high benchmark. Just below, AttenHScore achieves scores very close to that, and significantly better than using small language models alone, or simpler invocation methods like perplexity, which is a common measure of how well a language model predicts text, often used as a baseline for error detection. This clearly shows AttenHScore's strength in balancing performance with efficiency. So to wrap up our look at this research, it is clear the proposed AttenHScore is a really promising way to detect, in real time, when a small language model might be, well, hallucinating. This, along with smart strategies like uncertainty-aware re-ranking for systems using Retrieval-Augmented Generation, or RAG, enables a very effective collaboration. Ultimately, this means getting high-quality answers more efficiently, striking that key balance between performance and cost. That is all for this AI Research Roundup. Thanks for tuning in, and I am Alex.